It's science time. It's science time. It's science time.
Good morning, grade 8 students, and welcome to our Science Asynchronous Learning. I am Mr. Mark Joseph D. Elyongson, your Science 8 teacher. Since this is our first asynchronous learning, I would like to give you some tips in order for you to fully understand the content of this video lesson. First, it is much better if you use your headphones or earphones as you start watching this video lesson. Second, don't forget to jot down all the significant details. You can pause this video if you want to screenshot or jot down details. And third, you can watch this video several times for you to completely understand this lesson. In this video, we will continue discussing Module 1 and we will focus on the topic net force. Additionally, you will be given the opportunity to learn the following. Number 1, calculate net force. Number 2, identify whether an object experiences balance or unbalanced force. And number 3, determine the equilibrant force to balance all the forces acting on an object. There may be several forces acting on a particular object. It can be balanced or unbalanced, and we can determine whether it is balanced or unbalanced if we determine the combining forces acting on it, or commonly called as the net force. So what is net force? Net force is the sum of all forces acting on a particular object.
If you push this box with 10 newtons force and your friend help you by pushing with a force of 4 newtons, therefore the net force will be 40 newtons. The magnitude of the force can be positive or negative depending on the direction of the application of the force. The magnitude of the force is positive if it is exerted upward and negative if it is downward. It is also positive if it is exerted to the right and negative if it is towards to the left.
Net force, or commonly called as resultant force, can be calculated using this formula. F net, or the net force, is equal to F1 plus F2 plus F3 and so on, depending on the number of forces acting on a particular object. Let us consider this as an example. Take a look at this eraser and identify all the forces acting on it. What are the forces acting on this eraser? Number 1, there is gravitational force acted on this eraser. And number 2, the forces acted by this handle, which is what we call normal force. So now, let us identify the net force or the resultant force on this particular eraser. For example, this is the eraser, and there are two forces acting on it. The gravitational force and the normal force acted by the hand. Okay, let us assume that there is 10 newtons or negative 10 newtons acted by the gravitational force, and the hand also exerted 10 newtons, or the normal force which is also 10 newtons. So what would be the resultant force? Let us calculate the resultant force or the net force acting on the eraser. Net force is equal to F1 plus F2 since there are only two forces acting on the eraser. So F net, or the net force, is equal to negative 10 newtons plus positive 10 newtons. The net force is equal to negative 10 newtons plus 10 newtons is equal to 0 newtons. Remember, if the net force is equal to 0, the forces acting on a particular object is said to be balance. And if it is not equal to 0, all the forces acting on a particular object is unbalanced. So therefore, the resultant force acted on the eraser is balanced. Since it has equal magnitude and opposite direction. How about if the object experiences this kind of forces? Let us assume that this ball experience a 10 Newton force to the right and 5 Newton force, negative 5 Newtons force to the left. So what would be the resultant force? So let us use the formula for the net force. So F net is equal to F1 plus F2. Net force is equal to force number 1, which is 10 newtons, plus negative 5 newtons. So what would be the net force? So 10 newtons plus negative 5 newtons is equal to positive 5 newtons. So therefore, the object will move on what direction? So therefore, the object will move on the direction of a 10 newtons force, and we consider it as unbalanced. As I've said a while ago, if the net force is not equal to 0, the forces acting on a particular object is said to be unbalanced. So the net force is 5 newtons. So let us recall your topic in your Math 7 in addition of integers. So if you encounter addition of integers with different sign, usually the operation will be subtraction, even if it is addition. So for example, 10 plus negative 5. Tulad ng example natin kanina. So since they are unlike sign, we will use the operation subtraction instead of addition. So imbis na i-add natin si 10 kay 5, we will use the subtraction. So 10 minus 5 is 5. And how will we determine the sign? By following the sign of the bigger number. Which among the two is greater? So since 10 is greater than 5, so we will follow or we'll use the sign of the bigger number, which is 10. 10 is positive, so therefore the answer is positive 5. How about if we have negative 10 plus positive 5? Same case, we have unlike sign. We have negative and positive. So as I've said, if they have a different sign, you have to subtract. So 10 minus 5 is 5, and follow the sign of the bigger number. So as I've said, 10 is bigger than 5, so we will follow the sign of 10. So the answer is negative 5. For your information, another term for balance force is equilibrium. So the object is said to be in equilibrium if all the forces acting on it is balanced. If it is unbalanced, there is a certain force needed, or there is a certain amount of force needed in order for it to balance or to experience an equilibrium. So we have what we call equilibrant force. So what is equilibrant force? Equilibrant force is a force which balances other force, thus bringing an object to equilibrium. It is always equal to the net force but opposite in direction. So let us learn how to determine the equilibrant force. So the symbol for equilibrant force is Fe. Okay? And the symbol for net force is F net.
Remember that the net force is always equal to the equilibrant force but opposite in direction or in sign. For example, if we have a net force of positive 14 newtons, the equilibrant force will be automatically negative 14 newtons. And if we have a net force of negative 20 newtons, the equilibrant force will be 20 newtons.
So let's have another example of unbalanced force. So for example, a box experience negative 11 newtons downward and positive 20 newtons upward. So what would be the net force? And let us identify the needed force or the equilibrant force needed in order for it to balance. So let us first calculate the net force. F net is equal to F1 plus F2. So hanggang 2 lang siya kasi there are only 2 forces acting on the object. Pero in case that there are 4 or 7 or 10 forces acting on a particular object, hanggang 10 yan. So F net is equal to F1, kahit alin sa dalawa yung mauna. So pwedeng yung 11 newtons, negative 11 newtons, plus positive 20 newtons. So the net force is equal to, as I've said, if the two integers or the two forces are have different signs, so we have to subtract. So 20 minus 11 is 9. So we must follow the sign of the bigger number, which is bigger, negative 11 newtons or 20 newtons. So the answer is 20. So we will follow the sign of 20, which is positive. So the answer is net force is equal to 9 newtons. So is it balanced or unbalanced? So of course, the net force is not equal to 0. The answer is unbalanced. So if it is unbalanced, we need equilibrant force. Pag sinabi natin equilibrant force, ito yung force na magpapabalanse dun sa object. So dahil nga unbalanced siya, kailangan labanan yung another force para maging balance yung force. Ang tawag dun ay equilibrant force. So how will we calculate the equilibrant force? Sabi ko kanina, it is always equal to the net force but opposite in direction. So whatever the net force of the object, that will be also the equilibrant force, but we have to opposite the sign. So if the net force is 9 newtons, therefore the equilibrant force is also 9 newtons but opposite direction. So how will we do that? So by putting a negative sign. So if it is positive 9 newtons, the equilibrant force must be opposite, negative 9 newtons. Nakuha ba? Kung ang net force is equal to positive 10 newtons, the equilibrant force is equal to negative 10 newtons. If the net force is equal to negative 6 newtons, the equilibrant force is equal to the opposite of negative 6 newtons, which is 6 newtons. So in order for us to calculate or to determine the equilibrant force, we have to opposite the sign of the net force. Ganun lang po. So, ibig sabihin, kinakailangan ng negative 9 newtons force dito para mabalanse yung object in order for it to be in equilibrium state. So, negative 9 plus negative 11 is equal to negative 20. So, therefore, balance na siya. Negative 20, positive 20. Therefore, the object is said to be in equilibrium or balance. Kasi nga, same magnitude or equal in magnitude, opposite direction. So therefore, the object is said to be balanced. So let us consider this another example. So may box and we exert negative 5 newtons force to the left and another negative 10 newtons force to the left din, and on this side meron naman ditong positive 4 newtons force. So now let us determine the net force and the equilibrant force if it is unbalanced. So let us first calculate the net force. F net is equal to, since there are three forces, so we have force 1, force 2, plus force 3. So F net, or the net force, is equal to negative 5 newtons plus negative 10 newtons plus 4 newtons. So if we encounter 3 or 2 or more measurements, so we have to combine all like signs na measurement. So pag-combine muna natin yung lahat ng positive, pag-combine natin lahat ng negative. So negative 5 plus negative 10 is equal to negative 15 newtons. Combine muna yon. Then, since wala namang kapare si positive 4 newtons, i-retain mo siya. So now, let us combine this negative 15 newtons force to 4 newtons. So as I've said, if they have unlike sign, we have to subtract. So 15 minus 4 is 11, and we must follow the sign of the bigger number, and which is 15. So we have to follow the sign of 15, which is negative. So the answer is negative 11 newtons. So the net force is equal to negative 11 newtons. So therefore, if these 4 or 3 forces acting on this object at the same time, it will move on the direction of these 2 forces, or it will move to the left. So therefore, the object is unbalanced. So in order for it to balance, or in order for this object to be in equilibrium, we have to exert equilibrant force. Kailangan nating balansehin. So what would be the equilibrant force? If the net force is negative 11 newtons, as I said, we have to opposite the sign of the net force. So it is also 11 newtons but positive. So the equilibrant force is equal to 11 newtons. So meaning to say, kailangan ng another 11 newtons dito para mabalanse. Kasi negative 5 plus 10 is negative 15 newtons. Pinagsama mo yan. So kailangan daw ng another 11 newtons dito para mabalanse. So 4 plus 11 is also 15. Positive 15 newtons. So therefore, the object is said to be balanced, or the force is said to be balanced.
Today, we learn how to calculate the net force. We can calculate it by following this formula. Net force is equal to F1 plus F2 plus F3 and so on, depending on the number of forces. You also learn that if the net force is equal to 0, all forces acting on the object is in equilibrium, or in state of being balanced. And if the net force is not equal to 0, all forces acting on the object is unbalanced. And lastly, you learn that when forces are unbalanced, it needs an equilibrant force. An equilibrant force is a force which balances other force, thus bringing an object to equilibrium. The equilibrant force is always equal to the net force but opposite in direction or in sign. And that's all for today. I hope you learned something from this video lesson. You may watch this video several times for you to completely understand our topic. Thank you for listening and see you on our next video.
It's science time. It's science time.